Lower the middle-income countries suffer from the worst traffic death globally, according to the World Health Organization WHO. Road traffic accidents frequently cause orthopedic trauma, leading to surgeries for limb, hip, pelvis, and facial injuries. In response, our team has developed a cost-effective robotic system by transforming low-cost collaboration robot into advanced surgical robots. Our instrument features an articulation joint significantly enhances instrument dexterity, allowing surgeons to operate with precision in confined spaces. To further reduce costs, our system utilizes dental power tools and key components such as gears, bearings, and cutting tools. This enables our instruments to be powered by low-cost dental power tools, making them more accessible to a wider range of medical facilities. Setup and instrument replacement are streamlined. Simply attach the cannula for soft tissue retraction, and quickly exchange power tools like drills, screwdrivers, and burrs through a user-friendly interface. Once instrument is installed, the robot can be guided under haptic mode to accurately position instruments in the wounded area. We selected mandible fracture reduction as a test case because it involves complex drilling and screw placement in a challenging anatomical area. Our instrument features a 90-degree angle and an articulated joint, allowing for a 130-degree turn of the drill direction. This design enables surgeons to easily drill and place screws posteriorly, without the need for a drill guide. The robot can precisely align with screw holes on implants, ensuring safe and accurate drilling and screw placement. Our system has successfully completed rigorous preclinical trials using cadavers and is now poised for its first human trial.